invented. You see, when someone discovers something, they own it. So if we could teach our students to discover math, will it make a difference? Will it make them feel more comfortable? How many of you remember when you were, let's say in high school or college, you discovered some kind of, let's say a technique or a rule, and you came up with that rule in your own words. And I could bet you still remember it today. You know why? Because it's yours. You discovered it. And if we could teach our students that, it will make a difference. All right. You know, a lot of times when we teach, we start out saying, well, today we're going to talk about fractions. And a lot of times what we do, just by using the terminology or telling them what they're going to learn, we scare them. You know, I had a student, he told me once, for example, I know you see this brain here. It's not my brain. I don't have such colorful brain. But, you know, if we were to say something like this, today we're going to talk about fractions, this is what happens to a lot of our students' brain. It shuts down. They start thinking, oh my goodness, this is the reason I dropped out of school. I can't do that. It's scary. You see? So what I recommend, one of the strategies that I use in my classroom is that I make my students feel comfortable before I even introduce the definition or the terminology. I'm not saying the terminology is not important, but I make them feel comfortable first. So let's move on. If I were to give you something like this, I could bet you everyone that is looking at this, to them, that is very, very scary. Now, why is it scary? Usually when I do this training, you know, teachers tell me, oh, that squiggly line, or that F with the X in parentheses, and that strange looking D that is italicized. You know, the thing about math is made up of symbols. And our students are also afraid of symbols. But if we could make our students feel comfortable, then it would automatically make a difference. So let's move on, and I want you to take a look at this. And I know you could relate to this. This is in kindergarten. 3 plus 2, 5. We don't have a problem with that. But what if I were to bring it now with little piggies? Okay, now I have 3 little piggies plus 2 little piggies. Of course, that's going to give me 5 piggies. Well, we can do that. Well, instead of pigs, what if I replace the pigs with the letter P? And I say 3P plus 2P. If you notice, I'm using the exact same concept. So this should give me 5P. We don't have a problem with that. If I were to continue and I replace my pigs and my P, pigs and P, with this ugly symbol here, then automatically, you know, a lot of students, once they see the radical sign, it's scary to them. But you see, it's the same principle. If I were to add this using the same principle, I will get 5, let's say we don't know what that is, of whatever that is, right? What if I do this now? Is it the same principle? Yes, it is the same principle. So this will give me 5 of that. Now, if I were to bring this back to you, even though you don't know what the symbols are, okay, it's not as scary anymore. You see, I just removed the fear because I took you, I took it to a level that you can relate to. And I gave it to you in parts, little pieces at a time. Okay, so now you can say, oh, even though I don't know what this means, I know I could do something with it. You see, this would give me 5 of that. So let's take a look at the major difference between arithmetic and algebra. Now here I have some pigs, hogs, okay? And here I have some little piglets up here. And here you see the hogs, okay? So in arithmetic, this is what we'll generally say. We will say, okay, there are 10 pigs. And we could also say there are 10 animals. But in algebra, we'll say there are 8 little pigs and 2 big pigs. Or we can say there are 8 brown pigs and 8 black pigs. Now, when I'm face-to-face with teachers, generally I ask them this question. What's the difference do you see? Okay, what do you see that is different? And generally my teachers would say, well, arithmetic is very general, but algebra is very specific. And that is true. You see, algebra is very specific, and that's what throws our students off. So let's take a look at this. Since algebra is very specific, if I were to have 9 little dogs plus 5 little pigs, what would that give me? And of course, it should give me 9 little dogs and 5 little pigs, because algebra is very specific. Well, instead of dogs and pigs, let's replace D for dog and P for pig. What if I have this now? 9D plus 5P. What would that give me? Well, algebra is very specific, so I can't do anything with it. I just have to specify what it is. Now, what if I replace those with X and Y's? Algebra is very specific, so this will give me what? 9X plus 5Y. What if I do something like this now? Is it the same principle? Yes, it is the same principle. Okay, because algebra is very specific. And of course, we tell our students you can only add like terms. But a lot of times, it scares them. If they could see the reason why, it helps them. So in a case like this, 9x to the 4th plus 5y squared. Now, what if I have something like this? If you notice here, this is an orange pig. Some of you may see it red, but that's fine. And this here is 6 yellow pigs. Okay? Now, again, algebra is very specific. So what would that give me? 5 orange pigs and 6 yellow pigs. Well, what if I have something like this in algebra? Well, they're both x's, but they're not the exact same things, right? This one has a 4 as an exponent, and this one has a 2. So since algebra is very specific, I just have to specify what they are. Let's move on. If you gave your students something like this, it would scare them. But now that they see that algebra is very specific, I could use that same principle that we just saw, and we could solve this. It's not as scary anymore. You see, when I look at, for example, number 4, see, they're all the same things. So guess what? I can add them. I just have to add 7 plus 2 plus 8, okay? And that would give me 17 of whatever I'm dealing with. See, even before I introduce the concept of radical, I make them feel comfortable with it first. I make them feel, hey, you can do something with this symbol. And once they feel they could do something with this symbol, or with the symbol, guess what? You got them. You got them. All right. Now I have 1 hour, so I'm going to try to speed up, but I don't want to lose you. So I'm going to take my time, yet speed up, all right? Okay. I want you to take a look at this, and don't say anything till the end. Oops. Yeah, I'm seeing your faces. Yep, I'm watching you. Yes, some of you are making strange faces, right? You're saying, hey, this bottom number here, this last number here is incorrect. And if I were to ask you why, you say, well, it's not following the pattern. You see, the thing about it is that we learn by patterns. We use patterns in our learning, okay? I did this in a kindergarten class in Mexico City. And there was this little girl by the name of Lizzie. When I did this, she was sitting in the back. I did ask the principal to give me 5 kids that can add that are in a kindergarten class. So Lizzie, who was sitting in the back, when she saw this, she goes, ah, ah! And I said, Lizzie, what's wrong? So she comes up to the screen and she says, that bottom number is incorrect. I said, Lizzie, what is wrong with the bottom number? She said, it should be a 7. I said, well, Lizzie, why should it be a 7? She said, because you've been keeping the same bottom number every time. So she started walking off, and then she turned around and she says, and the top number is incorrect. I said, why is the top number incorrect? She said, because you've been adding the top number every time. So that should be a 5. Now, what did Lizzie tell me? Lizzie told me, without her knowing anything about fractions, she told me how to add fractions that have a common denominator. Not only that, if you notice in my fractions here, I have variables. I have x. She wasn't afraid of that. See, Lizzie now felt that she could do something. Now, I didn't talk about numerator. I didn't talk about denominators. I didn't talk about fraction bars. I didn't talk about anything. I just wanted Lizzie, I just wanted that group to feel comfortable with it. Okay? Of course, this should be, like we said, 5/7, right? You see, I tell teachers, use errors to benefit your students. Have them correct you. There's nothing wrong with that. Okay? And remember, whatever your students discover, they own. And let your students observe things on their own. They're going to learn math principles on their own anyhow. And that is very, very helpful for them. Okay. Now, the reason I use errors is because I was raised in Venezuela. Originally, I was born in Trinidad, a little island man. And in Venezuela, I had this teacher by the name of Mr. Padilla. Now, Mr. Padilla was one of these perfect guys. Everything was perfect. Well, one day, Mr. Padilla made a mistake on the board. And guess who corrected him? Moi. Yes, me. And from then on, I decided I'm going to pay attention to everything Mr. Padilla did so I could find another mistake. Well, guess who learned a lot of physics? Yep, I did. And guess who never made another mistake? Mr. Padilla. Now, how he felt, I don't know, but boy, I felt good because I corrected Mr. Padilla. Okay? Use errors. There's nothing wrong with that. And I know you teachers out there don't ever make mistakes, but that's okay. Okay. Now, I want you to take a look at this. And my little car is going to come in a little bit. And I want you to first tell me where the car is going to be located. Okay? And first you're going to tell me the street and then the road. So here comes my car. Okay? So before I put it up, can you tell me, I know I can't hear you, but just look at it and tell me where the car is located. And of course, it's located at 2nd Street and 4th Road. Okay? Your students could relate. Most of your students could relate to maps. All right? So I'm going to take this map now and take it into math. So I'm going to take it in what we call the rectangular coordinate system, or the grid, or the Cartesian coordinate system, as we mathematicians would say. Okay? And there's the car. So what I'm going to do now is ask you where it's located on the X and Y axis. So now you tell me it's 2 and 4. Of course, if you notice, I first indicated my X and then my Y. Now, because I can't see you, I like teachers to tell me what they see. And the same principle I use in my classroom. Because 90% of what they say as they do, they retain. When I'm teaching my classes, I always ask, well, why? What do you see? Okay? Because you see, while you're doing all the talking, they could be thinking, now this evening I'm going to do this, I'm going to do that. They could be thinking all kinds of stuff. But if you keep them engaged and you keep them focused, it really, really helps, especially in math. Okay, so the next thing I'm going to do now is replace my little car with a dot, which we call a point. So where is that point located? At 2 and 4. Okay? Now, I only have an hour, so I can't go into too much details. So what I'm doing is really giving you strategies. So let's move on. Now, could your students relate to this? And we all know it's a gas gauge, right? Well, guess what? In this gas gauge, I want you to take a look here, and you notice it says it's empty, right? So I'm going to take this gas gauge now and put it on my grid. And if I were to ask you if this is a positive thing or a negative thing, the first thing you tell me, oh, that's a negative thing. Nobody wants to have an empty gas tank. So if I were to draw a line through that, so if I were to have a line going in this direction, I would say I have a negative slope, okay? But of course, if the tank were to be full, like in this case, that's a positive thing, right? So if I have a line that falls in this direction, I say I have a positive slope. This is something that helps students understand if they see a line falling to the right or a line falling to the left, you know, if it's a positive or negative slope, okay? Also, I went ahead and created the types of slope. If you have a line in this direction, of course, it's looking toward it's in direction toward the full tank. So I say it's a what? A positive slope. If the line is straight, like this, horizontal, okay, I say I have zero slope. Now remember that I'm saying once the line is horizontal, I have zero slope, okay? Now, if the line falls in this direction, it's kind of looking toward the empty tank, then I have a what? A negative slope. But if the line is, it's vertical, totally perpendicular, then notice what I'm going to say here. We have what? No slope or undefined. There's a big difference between no slope and zero slope, okay? So keep that in mind. Zero slope, you have what? A horizontal line. But no slope, you have a vertical line, okay? All right, if you were to give your students this, how would they feel? Or if we were to give them this, how would they feel? Of course, it's scary. We're dealing with exponents. You know, our students are scared of exponents. But before I even use that terminology, exponents, I like to give them examples. But before I give you some examples and make you feel comfortable with it, I'm going to show you something else that scares them. If you give them an exercise like this and you say, simplify, oh my goodness. Oh, what about this? Oh, definitely it would scare them, right? So before I even ask them to do anything or teach them anything about exponents, I want to make them feel comfortable with exponents. So this is what I do. I give them a pattern and I ask them, try to figure out the pattern. See, I'm going to go a little faster with this pattern here. I hope you're looking at the pattern because I'm going to quiz you at the end. So what would this give me? Okay, and then everybody will say, well, it's an M with a little 10. Wrong. It should be an M with what? A little 7. Why? Why should it be a little 7? What was I doing? Oh, they tell me, well, you've been adding the little numbers. You see? A lot of times, because they see this multiplication sign here, they feel they have to multiply. But the pattern is telling them not to multiply, but to do what? To add the little numbers. And they start discovering that. You see, they start feeling, oh, I could do something with this. But if I were to start out and give them this, that scares them. You know, that's even how we write our books. We start out with this. And we tell them, well, a to the m times a to the n equals a to the m plus n. And boy, that sounds really nice mathematically, right? And it sounds like if I really know what I'm talking about. But the thing about it, it scares our students. In this way here, that you know, for them figuring out the pattern, they are the ones discovering the formulas. And they will feel more comfortable if they were to do that. So keep that in mind. Now, what math skill was needed for this? You remember we talked about the 4 basic math skills? if your students can add, they can figure this pattern out. Okay, it's very, very simple. And keep your patterns simple. All right, let's move on. Time is running out. So let's take a look at this and look at the pattern. So what would this give me? And of course, you'll say y to the what? The 12th. And then my next question is, how did you get that? So, you know, if your students can't tell you, well, you take, you multiply the exponents, you keep the base and multiply the exponent. I'm not looking for that at the beginning. I'm not saying they shouldn't know the terminology. I'm saying make them feel comfortable before you give them the terminology. So if my students were to say, well, you keep the letters or the numbers, the big numbers, and you multiply the little numbers, at the beginning, I will accept that, okay? Because I want them to feel comfortable with what they're seeing. And then later on, I will introduce the terminology, okay? So if I were to start with this, you'll scare them, I promise you. Most students are scared just by seeing this. But then the next question I'll ask is, hey, what is the basic skill that is needed to solve something like this? And of course, it's what? Multiplication. All right. Okay. Let's talk about some common basic uses of quadratics. You could use it as an expression. Okay. Somebody asked me to talk about this, so I'm going to introduce it here. And these are some expressions. Now, sometimes you'll have the equal sign, sometimes you won't. But these are all expressions. Okay. These are all quadratic expressions. Now, I want you to take a look at this side here, and I am going to give you some quadratic equations. Okay. Now, I want you to take a look at this here and this one here. A quadratic equation always has something after the equal sign, but in an expression, there's nothing. Now, when I do these, I don't tell them that. I want my students to tell me what they see. You see, once they can see it, they'll remember it. But if you tell them everything, then they go home and they say, now, what did that little man say again? And we want them to discover these things because guess what? It will stay within them much longer. So I want you to take a look at some other equations. Okay. These are all equations. All right. Now I want you to take a look on this side, and this is what I call a quadratic function. Now, if you look here, all right, I have this, but I have another letter other than x. Okay, these are what we call functions. Of course, in an hour, I can't go into all the details, but I just want you to see the difference between an expression, an equation, and a function. So here I have another function. If you notice, I don't only have a y, but I have f with something in parentheses here, right? This is also a function. This is also a function. And this is also a function. So these are all quadratic functions, all right? Okay. Now, a lot of teachers come to me and they tell me, well, you know, my students have problems factoring trinomial of this form. And I know there's a form that has a number in front of the x squared. If the coefficient is other than 1, you know, in this session, I won't be able to address that, but I'm going to show you how to solve one that has a coefficient of 1 in front of the x squared. Okay, so let's take a look at that one. Now, before I do that, I want to play a little game with you. I want to ask you which two numbers, when multiplied, well, actually, will give me 6, and when added will give me 7. I want you to think real quick. Bang, time's up. Okay, 6 and 1. Notice I said which two numbers, when multiplied, will give me 6, and added gives 7. I want you to take another one. Which two numbers, when multiplied, will give me 6, but when subtracted will give me 5. That would be what? Again, 6 and 1, right? Now again, if you notice, I asked you when what? Added or when subtracted. Okay, that's what we're going to emphasize here in the little technique that I'm going to show you in a little bit. All right. Now you can continue the game, and I'm just going to go really quick. Which two numbers when multiplied will give you 10 and subtracted will give 3? Which two numbers when multiplied will give you 24 and when added will give 14? Okay, I forgot to tell you one rule of the game, and you know what it is? When you give me the answer, you have to tell me the bigger number first and then the smaller number. All right. So if you notice, when I wrote these, I always wrote the bigger number and then the smaller number. The bigger number, then the smaller number. Right here, 12 and 2. Okay. So make sure, it's very important that you keep that part of the rule. First the bigger number and then the what? The smaller number. So let's move on. Which two numbers when multiplied give 20 and added give 9? 5 and 4. Okay. So let's look at a quadratic expression, and we're going to factor this trinomial. Okay, I'm going to give you this one here, and I'm going to try to take my time on this because I want you to see how I developed this. One of the major problems our students have with this is the signs. Okay, and I'm going to show you how you could find the signs without having to worry about it. So the first thing we have to do is open parentheses twice, right? And then, if you notice, I have an x squared here. The only way I could get x squared is if two x's are multiplied by each other. X times x will give me x squared. Now, I want you to see how I'm going to find the first sign. The first sign is always this one brought down. Okay? How do I find the second sign here? Okay, this is what you do. You multiply these two signs, and that will give you a positive. Okay? And that's the second sign. Okay. Now I have more examples, so don't worry. I'm going to show you another one. All right. Now, remember the game we were playing? We just played. This is a game here. Two numbers when multiplied will give, and here's where the number comes from, will give 10. That's always the last number. And when, notice I'm going to say when added. You see why I say added? I took this to tell me if I'm going to add. Will give 7. Now, what are those two numbers? What do you think real quick? 5 and 2. So I put my 5, the first number, because it's always the bigger and then the smaller number, right? So I put my 5 there, and then I put what? Then here's my 2. And it's done. Piece of cake, huh? Okay, let's do another one. If I were to give you something like this now, again, I open parentheses twice, all right? And this is what I do next. I have to put x and x. Now remember, the first sign is always this one here. So I bring this one down, okay? And then how do I get the second sign? I multiply these two. So that gives me what? A positive. Okay, so that is my second sign. All right. Now, what's the question I'm going to ask? I'm looking for two numbers when multiplied will give 14. Okay, and when, now notice I'm going to say subtracted because this is a minus sign here. See, this tells me what to do. And when subtracted will give 5. Notice I didn't put a minus 5. I'm just taking the numbers, not the signs, just the numbers without the sign. So what are those two numbers? 7 and 2. So I put my bigger number here. Always follow this step if you want to use this technique. The bigger number and then the smaller number. Okay? Now, I hope everybody got this. I'm going to repeat it in a little bit. But before I do this, what I do, I like my students to feel comfortable. And I give them little chunks at a time. Okay? Because you're the teacher, I showed you exactly all the steps in one. But what I do when I teach this, this is what I do. First, I have them find the signs. So this is how you do it. You open parentheses twice. You bring the x times x, and then you bring down the negative. How do you find the second sign? You multiply these two. So that gives you a negative, and that's the sign that I bring here. See, I'm not going to solve it yet. First, I have them learn how to find the signs, because that's one of the biggest problems our students have. And then now, I do it again. How do I find the signs? I know I go to put x here, and then x here, bring the first sign down, and then multiply these two to give me what? A positive, and that's what I'm going to put as my second sign. Do the same thing here again. Notice I didn't solve it. I'm just practicing with them to make sure they know what sign goes in each. Okay? All right. Let's bring that one down and multiply these two signs. That gives me a positive. And I do the same thing here. Okay, so x and x, bring the first sign down and multiply these two, and that gives me what? A negative, so that's my sign right here. Okay? So guys, I want you to see that once your students understand the signs, this is one of the most difficult parts. All right? Okay, let's move on. Factoring trinomial. I'm going to repeat what I just did a little faster. Okay, first of all, we had this. And once they understood the sign, now this is really easy to teach. See, you bring these two down because x times x gives me x squared. Bring the first sign down. And then once you multiply these two, that will give you a positive, and that's where you get your second sign. This is your question. Two numbers when multiplied will give you 10. And when you add them, okay, will give you what? Notice the second number, 7. See, when I was a kid, I was playing with these things, and that's how I came up with this. And I wasn't a weird kid, all right? But anyhow, you know, I realized that each of the numbers talk to each other. So that's how I got the 7 here. And then my answer would be 5 and 2, and I put my 5 here and my 2 here. And again, please remember the bigger number first, and then the smaller number. Of course, in this example, it doesn't matter, but in my next example, it will matter. So here we go. Okay, x and x. Bring the first sign down. Okay, multiply these two signs, and that would give me a positive, so that's what I put here. Okay, now the question, two numbers when multiplied will give me 14, not negative 14, and when subtracted, you see, this tells me what I have to do. When subtracted, okay, will give 5, not negative 5. All right. So again, we have 7 for the and 2. Now my big number is always first, so that goes here in the first one, and my second number goes here. Okay. Well, let's take a look at a few now. I want you, real quick, where you're sitting, I want you to try to solve number 3. Now, what I tell teachers, they can automatically tell if a number is factorable or not. See, you could look at a number and tell. Let's take a look at number 7 before you do number 3. All right? Because of time, I'm looking for two numbers that multiply will give me 10, and when I subtract them, I get 3. What are those numbers? Anybody? Okay, 5 and 2, right? Let's take a look now at number, let's take a look at number 12. Number 1. I'm looking for two numbers that multiply will give me 12, and when I add them, I get 7. See, it tells me what to do. 4 and 3. Okay? So now that you know that and you learn all this fancy stuff, guess what? Try number 3 on your own. Is it factorable first? Okay. All right. Now, because of time's sake, I'm going to put the answers here. So you have all the answers. and you can practice at home. Now you have homework. Isn't that wonderful? Okay, you can't say I didn't give you homework, okay? All right, let's move on. Now, if you notice, I have a function here, a quadratic function. Why? Because it is y. Whenever you have a quadratic function, you can graph a quadratic function. And the graph of a quadratic function is what we call a parabola, okay? In the islands where I'm from, they call it parabola. Hey, that's fine too. But anyhow, if you notice, a parabola looks like this, okay? And it opens upward when the coefficient, this letter right here, or the number that goes in front of the x squared, is positive. So if this number in front of the x squared is positive, automatically it opens upwards. All right, keep that in mind. It's a good hint for your students. But what happens if it's negative? You see, your parabola opens downward. All right. Now, a parabola has a point that either tells me go to the left or go to the right. You know, I call that my balancing point. Okay, but really the real name is vertex. So we have two vertices here, right? This is a vertex for when a parabola opens upward, and this is a vertex for when a parabola opens downward. All right. Now, keep this in mind, that if a parabola opens upward, we have what we call a minimum. Why? Because this is the smallest point that you could ever have. Everything else gets bigger, you see? This is the lowest point. But here now, this would be the highest point because everything else is getting what? Smaller on the y-axis, okay, y and x-axis. Of course, because of time, you know, I can't go into all the details, but I want you to take a look at this. We call this a maximum, and we call this one a minimum. Now, this C here represents where this parabola is going to touch my y-axis, and that's what we call the y-intercept. Okay, so here's an example. See, this is where the parabola is touching the y-axis, this point right here. Okay, let me give you it right there. You see it? And that point is represented with what? 0 and C. So the C tells me where it's going to touch the y-axis. And these are little hints that are very helpful to your students. Okay, any questions? Do I need to get out of my PowerPoint, Sharon?
Hi, Anthony. We do have a few questions here.
Okay.
And I read them off for you.
All right.
Well, one question is, are we going to be able to print Mr. Chan's PowerPoint?
Okay, what I did, I gave you an SWF, I gave it to Sharon, and you can use that in your classroom. You could, she could email it to you, or you could ask me and I could email it to you. And it has all the animation and everything that you see, but I can't give you the specific PowerPoint itself. But you have the exact animation in that SWF format that I'm going to give you.
Okay, great. And just so everybody is aware, and follow up to that, you will receive tomorrow, you'll receive an email with your certificate of attendance along with this SWF file that Mr. Chan is talking about. So you'll receive that. If you participated, you'll get that automatically from our system. Okay, going on to the next question. We have a question here. The thing that confuses me about a bit with exponents, I know my students can see the pattern, but that doesn't mean they understand it conceptually. I can figure out the pattern without understanding the fact, but the fact is crucial to really understanding exponents.
And I totally agree with you. They have to. The reason I show you the pattern, I show my students the pattern, is to make them feel comfortable at first. See, once they feel comfortable, then it's easier for you to explain it, okay? Because they feel, when I've taught it before, my students feel they can do something with it. And then when I started explaining the why, it was much easier for them to get it. If you start giving them all the, a to the m times a to the n equals a to the m plus n, it scares them. So that's why I always say make them feel comfortable first. The technique that I'm giving here is not to teach them exponents, but to make them feel comfortable. Once they feel comfortable and you start teaching it, it makes a difference. Try it. I promise you it will work. Make them feel comfortable first.
Great, thank you. Another question here is this session being recorded? And yes, it is being recorded. And it will be archived on the COIB website at coib.org/PD webinars. So this will be there as well. Another question, students would want to know why we have to put a large number in the first parenthesis.
Okay, they will want to know why. The reason it works, what I did, I took the quadratic formula and I turned it upside down. Now I can't explain that. But for now, you're going to have to tell them that's how it is, okay? But there is a reason why when you multiply those two numbers and you subtract, okay, let me go back to the file real quick. I'll show it to you. Let's see if I could pull that up. Okay, let me take the last one here. See, the only reason I could get a negative here is if the larger number is a negative. Okay, so that's why we want the larger number here. All right, and that's just a quick explanation of it. There are other ways to explain it mathematically, but right now the reason is because I want a negative, so the larger number should be here in order for me to get that negative. Okay.
Okay. Anthony, would you like a couple more questions?
Sure.
Okay. Is there a book or a document that expands with more examples?
I'm working on it. I'm creating a lot of PowerPoints that instructors could just take out from each PowerPoint what they need and work on it. I'm working on exponents, equations, fractions. So I am working on these things. When I go throughout the US and do my trainings, I always give little snippets of these. And of course, in an hour session or hour and a half, you can't give too much. But so that's why I decided to create those PowerPoints so teachers can use them.
Great, thank you. We have another question here. Do you have tips or suggestions for teaching adult students, or do you find that your methods work for them just as well?
Yes. No, this I have used with adults, not only kids, but with adults also. Okay,
great. We have a sort of a technical question. What is the difference between a quadratic equation and quadratic function besides the FX notation?
Well, you can solve a quadratic equation, and generally what you can do with a quadratic function, you can graph it. Okay, a quadratic function is kind of like a formula. Compared to a quadratic equation, you can solve it.
Okay, great. Another question, is this just for algebra or do you have the same format for elementary math?
I also use the same technique for elementary teachers and for high school. It's a technique that I've used in different countries, Trinidad, Venezuela, Mexico, well, here in the US, of course. And I get really good feedback.
Great. And then there was a number of people, Mr. Chan, who wanted to say that you did a great job. And this one person says, I'd like to thank you for your webinar and ask if you give other ones.
Well, I do want to thank COIB for inviting me. I don't know if they'll invite me back. So it's really up to COIB.
Well, we would like to thank you, Mr. Chan. We really appreciate this. You've done a great job. There's more questions here. Where might we find the PowerPoints that you've finished? I wish this webinar was longer. Will you have another webinar for quadratic equations? So I'll take a minute just to explain here quickly. What we do is we look at the conference presentations. So Mr. Chan presented at the national level last year and scored very highly. People loved his session. And so that's why we asked him back and asked him if he would do this professional development webinar. And we do tape these or record these webinars, and we archive them on our website. And I have another question here again about the certificate. And yes, everybody who attended this webinar will automatically receive a certificate. That's because when you log in and you register, that's how we're able to get your email address and send that directly to you. Okay, are there any other questions, or Mr. Chan, do you have anything else you'd like to say here?
No, I do want to apologize for the inconvenience at the beginning for technology, but hey, I think we overcame that, and I'm glad you attended, and I hope I've helped you a lot.
Yes, thank you all so much, and I hope that you'll attend our next professional development webinar, which is taking place in March. We'll send out an e-blast. We'll also post it to the website. And in the meantime, we wish you all the very best. Thank you so much.
Thanks. Bye.
Bye now.